We have seen various sections in integration, like we have algebraic calculus integration and parametric vector, means parameterization in vector. So, it's time to little bit we'll see in the differentiation area. So, integration, kind of too much PhD we have done. Now it's time for integration. It's time for differentiation. So when the integration is the most basic unit in calculus, so in calculus, integration is supposed to be the most basic unit. It is kind of parallel to the addition in normal mathematics. Then differentiation is kind of analogous to division or subtraction. So integration, when we add something, then in division, differentiation, we divide something. So integration to get the quantity, integration is to get the quantity. Okay, so integration is to get the quantity, then differentiation is rate of change in quantity. So if I have rate of change of quantity, then I can get the net quantity through integration. If I have net quantity, then rate of change in quantity I can get through differentiation. So integration and differentiation, they are opposite to each other. Like addition and subtraction are opposite to each other. Multiplication and division are opposite to each other. One is getting and other is giving. So subtraction is called addition only, but direction is opposite. So if I say that I get 10 mango, I get 10 mango, means 10 mango is coming to me. So direction is towards me. I get minus 10 mango. I get 10 mangoes, I get minus 10 mangoes. Means the mango is again in flow, but direction is opposite. So positive and negative, the difference is that they flow in same kind of line, but exactly in opposite direction. That is positive and negative. So positive means if this is positive, then this is negative. Okay, so repeated addition is multiplication, then repeated subtraction is division. So that is the concept. Now the basic unit of calculus is integration, because basic unit of mathematics is addition, not the subtraction. So if I have kind of a person is collecting 5 kilometer every hour he is collecting 5 kilometer, then how much he is collecting at the end of 3 hours. So 5 plus 5 plus 5, that in 15 hours he is able to collect at the end of 3 hours, or 5 into 3. So addition is 5 plus 5, whereas multiplication is 5 into 3. But the rate of collection should be smooth, constant, then only we can apply multiplication. So rate of collection if we have, then we through multiplication we get the net collection. Through addition we get the net collection. But if we see kind of the rate of collection is not constant, it is variable. Okay, so person at the zero time he is collecting 0 kilometer. At half an hour when he is checking, then he is collecting half kilometer per hour. At that moment, when he is checking at 1 hour, at the end of 1 hour, he is walking. So he is able to collect at that moment 1 kilometer per hour. You can say speed. At the end of 2.5 hours, he is collecting 2.5 hours per hour. At the end of 3 hours, he is collecting 3 kilometer per hour. Now, what is the total kilometer at the end of 3 hours? That comes as a question. Now, you cannot add because it is varying as per the hour. At the end of 1.5 hours, at that moment, he is collecting 1.5 kilometer per hour. So addition, I want addition, but simple addition is not possible. I want multiplication, but simple multiplication is not possible. Then people thought other way in a way that if this is x-axis, this is y-axis, and x-axis represent number of hours. So if this is origin, this is 1 hour, 2 hours, 3 hours. At the origin, person is at rest, whereas half an hour, his speed is half kilometer per hour. When 1.5 hour, speed is 1.5 kilometer per hour. 2 hour, speed is 2 kilometer per hour. 3 hour, speed is 3 kilometer per hour. So speed is growing. Okay, so at every moment speed is different. Okay, suppose that speed is constant, 3 kilometer per hour. I mean 5 kilometer per hour. So at zero time, speed is 5 kilometer per hour. Again, everywhere it is 5 kilometer per hour. So speed is constant over variation in the time. So speed is vertical. That is y-axis. So y-axis, the speed is vertical. So if speed is vertical, then 5 kilometer per hour is the speed. How much distance collected? 5 in first hour, 15 kilometer, 5 into 3, or the base is 3 r and height is 5 kilometer. If I compute the area, then it is the net collection. So if the graph is 5 kilometer per hour, the rate of change, then the area is rectangle, means height into breadth, 5 into 3, 15 kilometer he collected at the end of 3 hours. At the end of 2 hours, 5 into 2, 10 kilometer he had collected. So if area is also a measurement to give the addition, if I want addition, then area is also a way to measure. Then he starts from 0 and he make a kind of ramp. So he ramping up, and at the end of 3 kilometer, 3 hour, he is 3 kilometer per hour. At the end of 1 hour 45 minutes, his speed is 1 into means 1 3 by 4. So 1 and 3/4 kilometer per hour. So if this is the case, then I have to find the area of the triangle. That's it. That is the total kilometer volume. Area of the triangle is half the area of the rectangle. So if this is the triangle and end vertical is 3 kilometer, is 3 kilometer per hour, then the rectangle is 3 by 3. At the end of 3 kilometer, 3 by 3. Then area of rectangle is 9 kilometer. So means rate of change is variable into time, so 9 kilometer. Then the area of triangle is 9 by 2, 4.5 kilometer he has walked. So nice, right? Means if I calculate the area, then I get the net collection. That is integration. Summation, but where the rate of collection is as per algebra. So here the rate of collection is t. At any t, that is the rate of the collection. So if t is 10 hours, the 10 hours per hour is the rate of the collection. So the integration is nothing but it's a kind of rate, it's a calculation of addition based upon the area. So now if someone is very good in trigonometry then or algebra, then quickly he can find all the area whatever he wants. How much he walked from half an hour to 2.5 an hour. If half an hour wherever he was. So he started from 0 hour, half an hour he reached to some place. From there till 2.5 hours. So between 2.5 hours and half an hour, if I take hour from the origin only, then between these two, how much he walked. So it is as good as one triangle, that is 0 to 2.5 hours, another triangle 0 to half an hour, subtract. Okay, so 1 will become 2.5 hours by 2.5 hours is the height and 2.5 hours is the base. So 2.5 means 5 by 2 into 5 by 2, 25 by 4 divided by 2 because we want triangle. So it will become 25 by 8. Smaller triangle is again 1.5. So 1 by 4, 1 by 8. So 25 by 8 minus 1 by 8. 24 by 8. So 3 kilometer he was. So integration, like if I see, then it has two limits. One is at 1.5 hour, another is 2.5 hours. So what we do is we calculate the net area and we say half hour to 2.5 hours. So 2.5 hours. Like if it is the t is the algebra, then the integration of t is t square by 2. Means t square is area of rectangle by 2 means half, that is triangle. T square by 2. If I place limit half to 2.5, then t square by 2, 2.5 by 2, two and a half whole square by 2 minus 1.5 whole square by 2. So these are kind of definite integral. Okay. Anyway, what is indefinite integral? Means you don't have any limit beginning end. Whatever you get, like t square by 2 is in indefinite integral. So that is the area t square by 2. Now you have to think about the t. Okay, so that is integration. If this is integration, the differentiation is opposite to it. If t square by 2 is the integration addition, then what if t square by 2 is the net collection? If t, at any point t square by 2 is the net collection, t square is the area of rectangle by 2, then it becomes triangle. Then what is the rate of collection? If I know the collection, that is t square by 2, then what is rate of collection? So if formula is t, then integration is t to the power n plus 1 by n plus 1. Then if it is t to the power n plus 1 by n plus 1, then, and this is net collection, the rate of collection will become then t to the power n, opposite. So it will, if t to the power n is the formula, then rate of collection is the net collection, rate of collection, the differentiation becomes n t to the power n minus 1. So if t to the power n plus 1 by n plus 1, if I do differentiation, it becomes n plus 1 t to the power n divided by n plus 1. So t to the power n. So differentiation is nothing but opposite to the integration. Division is nothing but opposite to the multiplication. Subtraction is nothing but opposite to addition. So repeated subtraction is division, then that is differentiation. So if I have rate of collection and I want the net collection, I go for integration. If I have net collection, I want rate of collection, then I go for differentiation. Okay, so that is the concept of differentiation, basic concept. Now from here we would proceed. So I have a rate of collection is the, so now I have a collection graph. If I want differentiation, means I have a collection graph. So if we see the collection, that is t square by 2. Now I'll draw a diagram that is t square by 2. T square by 2 is the net collection. Suppose it is t square. The t square is the net collection. So if I draw, this is x-axis and this is y-axis, x-axis. Now if this is t, then drawing will be like a parabola. Okay, so if this is x-axis, this is y-axis, and x-axis is t-axis, then t square is parabola. If this is the origin, and this is x-axis with t, and this is y-axis, then this is t square. Means when t equal to 0, the height is 0. Otherwise, t is minus 1, minus, or t is plus. Y is always plus because it's a t square. So this is a parabolic shape t square. If this is a net collection, t square is net collection, then what is rate of collection? That is differentiation. Okay. Now from where to where we want. If I want from 0, if I want minus 2 to 2, what is the differentiation rate of collection? So t square means if I do the differentiation, then it becomes 2t. 2t. If it was t square by 2, then it becomes t. If it is t square, if it is t square by 2, it becomes t. That was the original working. If it is t square, then it becomes 2t. So 2t is the rate of collection, then the collection is net collection is T square. If T square is net collection, the differentiation rate of collection is 2T. Okay. Now in differentiation, can we see this graph again? Algebraic graph T square. So T square, from here the net collection is kind of, it is going down and then it is coming up. It is as if person is kind of walking from in negative section and he is coming to zero, and then again he is collecting. So now if I see T square, when T equal to 0, then T square is also 0. When T is negative, then T square is positive. When T is positive, then T square is positive. Okay, so differentiation is nothing but rate of collection, rate of change, rate of change. So if it is 2t rate of change, then 2t when t is negative, this side, then differentiation is negative. It is negative, right? What is rate of change? Rate of change means per unit change along x-axis brings how many unit of change along y-axis. That is the differentiation. Differentiation means rate of change. Rate of change means per unit change along x-axis brings how many unit of change along y-axis. So if I see this graph, and this is the origin, if this is the origin, then this side is negative, this side is positive along x-axis. Now if this is coming like this, if parabola is coming like this, then if there from here, so this is y-axis, this is negative x-axis, this is positive x-axis, this is y-axis. Now this side, if I am growing in x, positive direction of x, then y is decreasing. Y-axis left side means negative x-axis. From there, if I go along the positive axis, x is increasing, but still the y is decreasing. When it reaches origin, at that moment, from beyond that, when x is increasing, y is increasing. So rate of change is negative in this direction and positive in this direction. Can we see this? So the rate of change is negative and rate of change positive. This proves that at some point there is no rate of change at all. Okay, so if it is going down, if this is the graph of net collection, not the rate of collection, net collection. If this is the graph of net collection, then the rate of collection is 2t. If it is t square, the rate of collection is 2t. If it is 2t, then when t is negative, rate of collection is negative. Means per unit change along x-axis bring negative change in y-axis because it is going down. Okay, beyond this point, beyond this point, slight change in x direction brings positive change along y direction. So here the dy by dt is negative, whereas dy dt is positive. It is evident from the equation also. Okay, t square differentiation is 2t. So when t is negative, then the differentiation dy by dt, that is 2t, is negative. So per unit change along x-axis brings negative change in y-axis, where on right side per unit change along x-axis brings positive change along y-axis. So this is differentiation. But since it is changing like this, but at the origin, there is it is decreasing, becoming slow. The decrement is becoming slow, and here the decrement rate of change is 0, and then rate of change grows. This point is called extreme point, extrema. Okay, if this is extrema, then what it is? This is minimum. Means from here it starts and it comes to minimum, and then because y is positive, but dy by dt, rate of change is negative. So y is positive, y is coming down, and here y is means y is 0. dy by dt is also 0. Where there is no slope, there is no, I am not saying y, dy by dt. If I see the rate of change, if rate of change, there is no rate of change is seen, or rate of change is undefined. If I see t equal to 0, then 2t is the rate of change. At t equal to 0, the rate of change, rate of collection is 0. Collection is also 0, but rate of collection is 0. If rate of collection is 0, that point it is called extrema. Either it can be 0 rate of collection, or it can be undefined. So the point where the rate of change is 0 or undefined, that point is called extrema. Now you will say, what rate of change of 0? The t square equation is also 0. Okay. So if this is the origin, I am going to shift it here, 2 along the x-axis. Now the equation is that y equal to t minus 2 whole square. Y equal to t minus 2 whole square. So when t minus 2 whole square means when t is 0, y is 4. So it is not 0 at the origin. Now satisfied. So if this is the origin, then equation at this point, if this is the origin, now origin is shifted here. If this was the origin, now origin is shift the if this was the origin, then graph is shifted 2 in this direction. Now at the origin there is some height. If this is the origin, there is some height. Earlier it was like this. I shifted like this. Now at the origin there is some height. So the height is t square, means at minus when t equal to, so y is now t minus 2 whole square. So when t is 0, then it is 4. So there is some height. Now that is the equation. So now let's calculate the rate of change. So rate of change in the collection is t minus 2 whole square differentiation by dt. So that will come as 2 bracket t minus 2. 2, then again if I chain rule, if I differentiate it again, it is 1. So 2t minus 4. 2t minus 4. That is the differentiation. Now when t is negative, when t 2t minus 4, when t is 0, then it is 4, again negative. When t is negative, anyway it is negative. When t is 2, then it is 0. So the rate of collection, what we are seeing, the rate of collection is 0 when t equal to 2. Otherwise it is not 0. So earlier the parabola was like this. Now I shifted right. Now at this point, if t is 0, then rate of change is minus 4. When t is 2, then rate of change is 0. Beyond that it is positive. So from t is negative till 2, not till origin, 0. Till when t is negative till t is 2, the rate of change, if I keep incrementing x, then y is coming down. Rate of change is negative, and when t equal to 2, it is 0, and beyond that, it is rate of change is positive. So when t equal to 2, then dy by dt, that is 2t minus 4 equal to 0. So rate of change, when we see the rate of change, anyway, if you see the graph also, it looks like that. Means there is slope, rate of change is slope, because it is changing, right? So rate of change is decreasing, 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 and here it looks like it is taking another turn. So from decreasing to increasing, suddenly there will be something, there is something happening. Decreasing to increasing means there is something happening every time. So their rate of change is 0. If at a point rate of change is 0, then it is called either minima or maxima or not defined. So rate of change is 0 or not defined, then it is called minima, maxima, or just an extreme point, not defined. So here it is called minima. Can we see it looks like minima. Everywhere it is high and only this location it is. So at minimum it can come to this level and then it will go up. Everywhere it is up only, it will come minimum. If I tilt this, then it is always low, it is coming high, and here it is becoming maximum and then coming down again. So here it is maximum. Okay, if it is a cone, cone means, okay, cone means cone. So this is cone. Can you see it is ascending, and here there is a sharp point. Okay, so that is cone. Okay, so this is kind of a, this is cone. This is cone. From here it is ascending, and here it is suddenly it is decreasing. There is no gap there. Here there is a gap. If it is ascending, then there is a flat little bit, and then it is coming down. But if it is a cone, then from here it is ascending, and here there is no rest point. There is no point at all. And suddenly, so we will see that. So here it is kind of like y equal to root t. Y equal to root t. Okay, if y equal to root t, then what will be the differentiation? T to the power 1 by 2. Then it will become 1 by 2 t to the power minus 1 by 2. 1 by a square root of t. 1 by, or 1 by a square root of t. Okay, or I can say t to the power, we'll see this. So cone in 2D, in 3D, I think it would be better to see. If it is t to the power 1 by 2, then it is 1 by 2, 1 by 2 into 1 by square root of t. This is what we are seeing. So when t equal to 0, it is undefined. I think we are getting it. So when t equal to 0, so if this is the equation of cone, if this is equation of cone, and then, okay, so when t is negative, okay, so when t is negative, then we have some value. When t becomes 0, and then t grows. Okay, so when t is kind of minus 3 or something like that, then square root of something, we will see more on it. But think about a kind of a situation like this. So when t equal to 0, at this point, it is the differentiation is undefined, because there is no point at all. It's coming sharp and going sharp. So these are the point of extrema where the rate of change is either 0 or undefined. If it is 0, then it is either maximum or minimum. So if it is maximum, then the equation for the maximum would be, if it is y equal to t square is the equation of minimum, then if I tilt it, means turn it down, means negative. So y equal to minus t square. If I do y equal to minus t square, then what will happen? If t is negative, then it is minus. If t is positive, it is again minus. Y equal to minus t square. So if this is the origin, then it is always negative. At t equal to 0, it becomes t 0, then again negative. So this is the difference between positive and negative, addition and subtraction. So if this is positive, then if you do the I negative, then it is exactly other way. So difference between positive and negative in direction, not the amount. Okay, amount is same. The graph is exactly same. I just tilted it. So if this is positive, then it is negative. Negative. That's it. So if it is y equal to t square, is everywhere y is positive, and when t equal to 0, it is 0. Then y equal to minus t square is everywhere it is negative, and when t equal to 0, it is 0. Now differentiation is minus 2t. If that is the case, then with t equal to 0, the rate of collection is 0. Otherwise, it is not 0. But here, when it is 0, rate of collection, there it is maximum. Whereas if y equal to t square, then it is minimum. Okay, minima, maxima. Now in cone equation, later we will see in 2D, that will be kind of Nice, because the cone equation is x square plus y square square root. So if I say t square root, then it will be like a plus minus t. That will be t square square root. It is not kind of the so neatly we'll get that we'll get in x square plus y square square root. That is the actual equation of the cone. So we'll see in 3D. Anyway, in 2D now, we have if our rate of collection is 0, then either it is maxima or minima, or if rate of collection is undefined, then it is also a critical point or extrema. So extrema is also called critical point. So that is the case. So nice. So it is. Now question arrives that if I say this is global minima, this is global minima. Global minima means after this I know it is going to increase only forever. After this I am going to increase forever. If it is increased forever, then certainly there is only one minima. So I can call it global minima. Global minima means if the region, now I am calculating the region. So in this region, any region, this is the only minima possible. Or any region, if y equal to minus t square, then only one maxima possible. What about the sine wave? Sine wave, when it is at origin, then it is 0. Then it grows like this, it reaches